project is experimental testing on unpaved roads using geocells. Presented by Aravindan R.K., Mohammad Aksan, Soundarajan M. Our project guide Mr. L. Talabadi R.T., Assistant Professor of Civil Department, Veltech. Nowadays, maximum rural roads are made up of unpaved roads which have less soil stability and thus easily get eroded, and so the maintenance cost for this type of roads are deliberately high. Technological innovations in geosynthetics, that is high modulus geocells, can help to achieve a more sustainable roads. In this study, soil with geocells, soil with coarse aggregate and soil with coarse aggregate and geocells with infilled materials were tested and compared under repeating loadings. This study experimentally investigated the effect of geocells reinforcement on the permanent deformation of minimum settlements and percentage elastic deformations of granular bases. The test results shows that the geocell reinforcement reduced the permanent deformations of settlements and increased the percentage elastic deformations of granular bases. Soil with coarse aggregate and geocell reinforced sections demonstrated even better performance compared with other sections. Introduction. There has been a huge investment undertaken in India to build and upgrade the transportation infrastructure, where the challenges are more than budget. Many unpaved roads in rural areas have prime problems, that is, lack of soil stability. Here, a sustainable unpaved road pavement can help to face these challenges by improving the long-term road strength and rigidity. Cellular confinement systems, that is 3D honeycombed polymer matrices formed by interconnected strips and infilled with compacted granular infill, have been used to confine unbound aggregates in the base layer of unpaved roads. The literature review validates the geocell contributions to pavement performance. The key mechanisms in geocell reinforcement that improve pavement strength by lateral and vertical confinement. Lateral confinement of infilled materials prevents movements and shearing under loadings. Frictional resistance between the infill and cell walls are higher and so restrains soil from moving upward outside under the loading area. Thus, the aggregate lateral movement are minimized while the distribution of lateral and vertical cells are maximized. Aim to provide the stable unpaved roads in rural areas using geocells. Objectives: to study the existing soil conditions of road surface, improvise the soil stability of road surface by using geocells. Methodology: literature review, collection of materials, testing of soils, testing of materials, analyzing the performance of the soil and materials, stability check, result and conclusion. Some literature reviews are taken for exam and reference to our project. These are experimental study and geocells stabilize unpaved shoulders, and determination of carbon black content in HDPE, use of geocell for improved railway performance on subgrade, numerical analysis on burette pipes protected by geocells and rubber, axle-type pavement testing of unpaved roads with geocell reinforced sand bases, high modulus geocells for sustainable highway infrastructure, geocell reinforced foundations, evaluating the applicability of geocell treated sand. These cellular confinement systems are in 3D honeycomb polymer matrices found by the interconnected strips and infilled with the compact granular infill. There are two types of geocell material: HDPE, which are made up from the polyethylene, Botkin bars, paper and cardboard waste; NPA, which is commonly known as neolite. Properties of soil surface: soil type, maximum dry density, shear strength, value of cohesion. And then we have see about the test of soil test. First we see preliminary core cutter test. By using core cutter method, bulk density of soil can be quickly calculated, and by determining the moisture content of soil, the density of the field can be calculated. And then it's the white percentage. A high percentage of whites indicates poor compaction of soil. Below the calculations are verified, and this is the table for core cutter test. And say liquid limit test. The liquid limit is the moisture content at which the groove found by standard tool into the sample of soil taken in the standard cup closes for 12 mm and being given 25 blows in a standard manner. This is the limiting moisture content at which the cohesive soil passes from liquid state to plastic state. We have three trials. Trial 1, liquid limit test table are here. These are laboratory fields. Plastic limits. The water content at which soil sample change from plastic to semi-solid state. Plastic limit is the water content in a clay soil below which it stops to behave like a plastic material. It starts to crumble when rolled in threads of 3 mm diameter. Trial 1 calculations, and its table. Plasticity index. The difference between liquid limit and the plastic limit is known as the plasticity index, and is in the range of water content that the soil has a plastic consistency. The consistency of most soils in the field will be plastic or semi-solid. Result is 13.51%. Specific gravity. Specific gravity of fine aggregate is the ratio of weight of given volume of aggregate to the weight of equal volume of water. Formula and also have a table. Proctor compaction test. The Proctor compaction test is a laboratory method of experimentally determining the optimal moisture content at which a given soil type will become most dense and achieve its maximum dry density. It is generally defined as a densification of soil by the removal of air and rearrangement of soil particles through the addition of mechanical energy. The energy exerted by compaction forces the soil to fill available voids, and the additional frictional forces between the soil particles improve the mechanical properties of the soil. Because a wide range of particles are needed in order to fill all available voids, well-graded soils tend to compact better than poorly graded soils. Here we have a calculation and tables, and the result of maximum drain density is equal to 2.094 gram per centimeter cube. And unconfined compression test. The unconfined compression test is the method of soil shearing testing for measuring shear strength. This method is used primarily for saturated cohesive soil recovered from thin-walled sampling tubes. The unconfined compression test is inappropriate for dry sands. Dry sands are crumbly clays because the materials would fall apart without some land of lateral confinement. In this table, average stress 0.0561, 0.5723 of compressive stress, shear strength of soil Qu by 2, compressive stress P by AC Newton per mm square is equal to 0.0280, and compressive stress kilogram per centimeter cube is equal to 0.2861. Sample California bearing ratio test. The California bearing ratio is a penetration test for evaluation of the mechanical strength of natural ground. Subgrades and base course beneath new carriageway construction. The CBR rating was developed for measuring the load bearing capacity of soil used for building roads. Here I have a table, and we taken at 2.5 mm penetrations of PRPR 43 load 1100.8, and standard load is 13,413.7 versus 8.19. At 5 mm penetration, PR7 load 1,894.4 and standard load per Newton 20,159.55, 94% of CBR. And next we have testing the coarse aggregate, and here the first test is preliminary test, abrasion test. Abrasion test is carried out to test the hardness properties of aggregates. Principles of Los Angeles abrasion test is to find the percentage of water due to relative rubbing action between the aggregate and steel balls used as abrasive charges. Here the table, average of Los Angeles abrasion is equal to 31.34%. For waterborne macadam, maximum wear is 60%, hence it is good. Here is a sample water absorption test. Water absorption gives an idea on the internal structure of aggregate. Aggregate having more absorptions are more porous in nature and are generally considered unsuitable. Others found to be suitable based on strength, impact and hardness test. Here is the calculation. Water absorption percentage is equal to 1.33%. Specific gravity test. The coarse aggregate specific gravity test is used to calculate the specific gravity of a coarse aggregate sample by determining the ratio of weight of the given volume of aggregate to the weight of an equal volume of water. Specific gravity is equal to weight of aggregate divided by weight of equal volume of water. Here is a sample, and it has a 3 trial for specific gravity test. An impact load test. The aggregate impact load test is carried out to evaluate the resistance to impact on aggregates. After the load impact on the aggregate, it is allowed to pass through 2.36 mm ISA, and then the impact load value is measured as a percentage of aggregate passing 2.36 mm sieve to the total weight of the aggregate sample. Cylindrical measures of equipment is equal to 0.914 kg and have a 3 trial for impact load test. Aggregate equal to less than 10% is equal to exponentially strong, and 10 to 20% is strong, 10 to 30% satisfactory, greater than 35% is weak. Our aggregate impact load value is equal to 15.5%, and aggregate use rubs are strong enough for laying roads. Properties of geocells have carbon black content, environmental stress, crack resistance, tensile strength, durability. And here are the properties of the geocells: thickness, height, welding distance, carbon black content, environmental stress, crack resistance, units and values, tensile strength, distance at maximum percentage 15 values, durability predicted to be durable for minimum 40 years of soil with 4 less than 3 years less than 9. Model road setup. After testing of soil, we are excavating a pit at 450 mm with a length of 4 meter and a breadth of 1 meter, in which infill the fine grained soil and compact. After compaction, infill the gravel and compact. After compacting of gravel, geocell have been included under the subsurface soils. It means debris soils are filled and compacted. Chemical setup. Wooden box, the box of dimension 0.60 mm into 0.40 mm into 0.30 mm. Fabricated using plywood sheets. Geocells made up of high density polyethylene, thickness 1 mm, height 150 mm, welding distance 465 mm, durability minimum years of 40 years of oil, and bearing plate. Backfill materials. Backfill material used for construction of road is taken from near New Elano, Chennai. Preliminary tests of soil identifications are carried out in the laboratory to determine the backfill properties. The soil has same sieve size of 4.5 mm as used in all tests. Procedure: rectangular bearing plate of dimension 0.06 mm into 0.08 meter is placed on the top surface of road. A series of dead load is applied on the plate. Dead load used in this case consists of precast beams and cubes. A beam is first placed over the plate and settlement corresponding to that is observed. The value of settlement is taken when the dial gauge starts showing constant reading. The load and the corresponding settlement of road is measured by dial gauge installed. The road is then installed with the geocell and the load is applied on the plate. In addition to the load settlement measurement, the deflection of the geocell under increasing dead load is also measured. Here the test for results for the settlement stress for different layers. Determine the settlements at different layers of unreinforcement. Unreinforced sites combined with coarse aggregate geocells and coarse aggregate with geocell. Thus the settlement was determined by increasing the load at different intervals. Thus the settlement was measured by using dial gauge. After determining the settlements, we have to compare the different layers and the result is given below. Here is a comparison table and the graph of settlement of layers. Plate load test is plate bearing test is the load bearing test of soils for determining ultimate bearing capacity of ground and likely settlement under given load. A factor of safety is applied to give the safe bearing capacity of soil. Plate load test is done to site to determine the ultimate bearing capacity of soil and the settlement of foundation under load for clay and sandy soil. Plate load is most conclusions. In the project, stability of unpaved road using geocell is compared to conventional unpaved road. The strength of unpaved road is increasing using geocell as the reinforcement material. Result of the preliminary test of the subsurface soil and coarse aggregate shows the ability to withstand wear and tear. In our research shows the permanent deformation of settlements is highly reduced. So rainfall has been easily drained and the maintenance cost is highly reduced. From this, we concluded that the geocell used strength and stability to the conventional unpaved road. So we can provide it is a reinforcement for conventional unpaved road. These references. Okay, thank you.